All right, now it's finally time to do the hard part. We're gonna write our own algorithm that will find the lowest cost. And this is the famous gradient descent algorithm. And gradient is, well, you guessed it, just another word for slope. So I'm going to give you a very, very Austrian perspective to think about the gradient descent algorithm. You know, we've got a lot of mountains back in Austria, and they're very, very beautiful, and you can go ski down them. But a mountain is a force of nature. You have to respect the mountains. You see, the weather can change very, very quickly. And this is especially unpredictable in winter and at high altitude. So, you know, imagine yourself that you've wandered off the beaten track and the fog comes rolling in. And at this point, you find yourself in a survival situation. This is when you can't see very far and you can only feel the ground beneath your feet. The cold is going to be creeping in through your jacket and you find yourself thinking, how do I get down? How do I get back down? Well, to figure out which way is down and towards that hot cup of tea waiting for you at the end of your journey, you gotta feel like which way is down. What is the slope, right? You're gonna look at your feet and you're gonna figure out that the fastest way down is in the direction where the slope is steepest, right? Where the descent is the most steep. And if you take a step downwards in that direction and then kind of get a feel for it again, like which way is the slope, and then take another step where the slope is steepest, you'll be down in that valley in no time and you can sip on that hot cup of tea, right? And this is how you can think about gradient descent. Except instead of a mountain, gradient descent is going to take place on a cost function. And the cost function actually doesn't tend to look like this. It doesn't kind of have a peak, if you will, right? Because if a function had a peak, then it would be called concave. It has a maximum. But with our cost functions, we're going to be looking for minimums, right? So if you imagine that mountain flipped upside down and all you've got is a valley, right, that you have to kind of find, then your cost function is going to look more like this. This is a kind of function that's called convex. It'll have a minimum, and our job is to get to the bottom of it, because that's where the cost is lowest. Now, gradient descent isn't always called gradient descent. There's another word for it that you might see as well in the literature. Sometimes it's referred to as steepest descent. And yeah, it's an optimization algorithm for finding the minimum of a function. So, you know, to think about our mountain example, to find the minimum, the function takes these little steps, right? It takes a step in the direction where the slope is steepest, in the direction of the negative of the gradient. And bit by bit, ends up in the bottom of the valley. All right, so let's implement this in Jupyter Notebook. Let's add another markdown cell here. And I'm going to go to cell type markdown, and put 2 hashtags there for a section heading. And that section heading is going to be Python loops and gradient descent. Now, if you're a seasoned programmer, you're going to be familiar with writing loops. But if you're new to Python or you're new to programming, then the next couple of minutes are going to be the introduction to this topic of loops. Loops are little bits of code that are executed over and over again. We're going to walk down that mountain. We're going to walk down into the valley with our gradient descent algorithm. So this is going to be a very, very useful tool for accomplishing that, because our algorithm has to complete that famous 3-step process, right? Predict, calculate error, and learn. And repeat. So instead of writing the same Python instructions over and over again, we're going to be using loops to simplify that for us. Speaking of for, this is the first loop I'm going to introduce to you guys. So this is going to be the for loop in Python. So I'll I'll just write a little comment here. Python for loop. And this is what the syntax looks like. We're going to have the keyword for, and then there's going to be a variable. In this case, I'm going to call it n. And then another keyword, in, and then I'm going to say range, parentheses, 5, colon, new line, and now we're inside the loop. And here we're going to print famous first words, hello world. Okay? Let's hit Shift Enter and see what happens. All right, so we've printed hello world 5 times, right? 1, 2, 3, 4, 5. If I change this range to 3, it'll print it 3 times. If I change it to 1,000, it'll print it 1,000 times. But let's stick to 5 for the time being. And let's take a closer look at this value n here, right? N is just a variable, and it's going to keep track of how often our for loop has run. So if I say hello world, comma n, then I can see what the value is of the variable n each time the loop is run. So it starts at 0. Programmers like to start counting from 0, and that's the very first time the loop runs. Then this print statement is executed another time. So second time, third time, fourth time, fifth time, and at this point the loop stops, right? Show you that. Print end of loop. So the Python program will come in here, it'll execute whatever's inside the loop, and you can tell what's inside by the spacing, a predefined number of times. In this case, 5 times, right? 0, 1, 2, 3, 4. Now we can call a little counter variable here n. We can call it I. This is another one that is often used. So if I call it I, I get exactly the same result. It really doesn't matter what you call it. You can call it counter. As long as you're consistent, you can access the variable, the looping counter, inside of the loop by its name. All right, so that's the for loop. It executes a predefined number of times, and it's got this very, very simple syntax. For n, in, range, and then some number here. So this is how oftentimes you want to execute the loop. With that out of the way, let me show you another type of loop. This type of loop is also very, very common, and this is the so-called while loop. Yeah? A while loop works a little differently, right? It has a condition that it checks every time it runs, right? So it'll check the condition, and then if that condition holds, it's going to run the code inside the loop. And it's going to continue doing that until the condition fails. So if I have a counter and I say it's equal to 0, and then I can write my while loop like this. I can say while, which is a keyword, and say counter is smaller than, I don't know what, 7, colon, print counting counter. So I'll print the value of my counter inside my loop, and then I'll say counter is equal to counter plus 1. So I'm going to increment my counter variable by 1 every time the loop runs. And then when I finished with the loop, I'll print something else. Yeah. Ready or not, here I come. Yeah. Let's make that loop a little bit more menacing than the last one. So if I hit Shift Enter now, I can see my print statement inside my loop executed 7 times, right? Starts at 0 and executes it until our condition fails. This is the condition. So whatever follows the while keyword is the condition that's checked. And this fails when counter is equal to 7, because 7 is equal to 7. It's not smaller than 7. So this will be false. At this point, the loop terminates and the code inside is not executed anymore, and we jump to our print statement below, right? This one, ready or not, here I come. And this is what we're seeing here. Again, I can accomplish the very, very same thing as with the for loop. So I can execute it 5 times. So if you want, you can also execute a while loop a predefined number of times. But yeah, there's a small catch. There's a small gotcha that can happen with while loops that you won't get with for loops. Any guess what this gotcha is? Any guess what it is that can trip you up and where you can shoot yourself in the foot? So with while loops, you can get into a situation where they don't stop, where they don't terminate. So for example, if I had made a typo here, and instead of that plus, I had hit minus, then my loop would actually run forever, right? Because it would start at 0, then when it reaches this line, my counter would go to -1, then would come here and go to -2, and then would come here, -3, and this thing would just continue going, right? Which is clearly not my intention, right? It would continue going and cause a lot of problems. So with while loops, you have to be careful that you don't accidentally write an infinite loop. Yeah? So for loops, by their very nature, run a predefined number of times. While loops run while a certain condition holds true. And this is where you gotta be careful. So with your while loops, you gotta make sure they terminate. And the easiest way to remember this is with an old programming joke. Yeah, that goes something like this. A programmer once said to his wife, "Honey, I'm heading to the supermarket to buy some groceries." To which his wife responded, "While you're there, buy some milk." And alas, he never returned home again. Oh, crickets. Back to gradient descent. Let's tackle that in the new cell here at the bottom. The thing with gradient descent is that we need a couple of ingredients, right? We need a starting point, then we need a learning rate, and we're going to need some maybe temporary value to hold on to something while our program is executing. So I'm going to create these 3 things here. I'm going to say new x, which is going to be our starting point. I'm going to set it equal to 3. We're going to start with 3 as the starting point. I'm going to say previous x, and this is going to be my temp value, if you will, that only matters inside of the loop. And then I'm going to also specify a learning rate, yeah, or gamma, or whatever you call it. So I'll call it a step multiplier. And I'll set it equal to 0.1. Now it's time to write that loop. So it's going to be a for loop for us. So I'm going to say for n in range, and maybe start at 30, colon. And now for the first step. What's the first thing that we have to do? Well, we have to make a guess, right? We have to make some prediction. This is step 1 of the machine learning process. So I'm going to take our temp value, previous underscore x, and I'm going to set it equal to our random guess, yeah? New x equals 3. 3 was a random guess, just our starting point for our gradient descent. So I'm going to set them equal to each other. Now we get to step 2. Step 2 is calculating the error, because we need to know how far off we were. Now from the previous lesson, you will know that the steepness of the slope tells us how far off we are, right, from the minimum. Because at the minimum, the slope is equal to 0, and everywhere else it's equal to some number that isn't 0, right? So our gradient is going to be equal to df of the previous x, yeah? So we're going to call our derivative function. We're going to pass in the temp value, so at the point where we are in our function, and I'm going to store the slope, yeah, at this point in a variable called gradient. So one thing you might ask at this point is, why is calculating the gradient step 2, where we're calculating the error? What's the link between those two things? And the way to think about it is that the further away we are from our minimum, the steeper our slope. So if the slope is very, very steep, then it's indicative of being very, very far away from where we want to be. A steep slope means that we've got a high error, and if the slope is 0 or close to it, then our error is small. And now it's time for that adjustment step, for that learning step.